Recording.
Would you have our cam that the people can see a bit better? Yes. Because our owl is getting blurry over the day. She's getting headache.
There we go. Nice.
Great, thanks.
Hello, you can see me.
Triple.
Full back camera that is a bit blurry, but I mean. Okay, good. So, yeah, this session will talk about the work that we've been doing. I would say in the last year and a half now, about introducing the software requirements in the Linux kernel development process. Well, indeed, as many of you are aware, I mean, today the Linux kernel development process is mainly governed by the expert judgment and the maintainers, right? So, indeed, they decide whether code submissions are good if they meet the expectation of the intent. However, such intent is mostly missing, especially for low-level functions. Okay, and this indeed increases the technical depth that is associated with Linux, with the Linux kernel. Okay. So so what we did, the past few years. So I mean, this is the agenda. First, I will cover the past activities. Then I will discuss the feedbacks, the current feedbacks from the community, and then I will tell you about the current activities and challenges and next steps. First thing we did here is we evaluated we wrote a document where we evaluated the existing Linux kernel documentation against the goal of the standard, of the safety standards. And as an example, we considered the goal of ISO 26262. And if you're curious, you can click on this link. Actually, if I click it, well, if I click it here, it doesn't show because I'm sharing the tab. I should share the window. But let me do it quickly for 1 second. So let me stop sharing and share again. Share the windows, or maybe let's show the window. Basically here, right? So if we click here, this is the document that we put together, right? So, and we explained the goal, the rationale, and here basically what we did, here you can see the software architectural design objectives, and we mapped the available Linux kernel documentation to this goal, right? So at the end of the day, I mean, now I don't want to spend the entire session on this because this is not the main topic. However, the interesting part here is that for low-level function today, the guidelines say that the exported symbols at least should be documented. Okay? And we assessed how many of them were documented, and across 6,069 source file exporting symbols, only 547 of them are cross-reference from the Linux kernel documentation. So it means that more than 90% of the exported symbols are not coming up in the Linux kernel documentation. Okay. And so this is just to tell you what is to what extent they we have a gap, right? So we decided that somehow this gap should be filled. and how. After this, so basically what we did here, we presented a session at the Linux Plumber of 2024, where we presented, the result of this work, of this assessment, and the different maintainers, agreed that technical debt is present, that must be filled, and that the requirements should be defined. That's what the Linux kernel. One of the main outcome from this session of Plumber is that requirements should be defined and maintained along with the Linux kernel code. Okay, so requirements should be defined to get next to the code. Okay, and they should be maintained next to the code submission. Okay, then after this, we started working on the requirements. What we did, if you click on this hyperlink at the top, there is a document that explains, why we are doing this, and that proposes, a requirement format, and you can see the summary of this format here. Okay, and indeed, there is a requirement ID that is, immutable, and that, uniquely identify a requirement. There is a requirement and fields to define when a requirement is ending. So, there is an SPDX requirement ref to cross-reference the requirement between each other. There is an hash key that is needed to evaluate when requirements must be updated. So basically, the code that belongs to a certain requirement is hashed together with the requirement itself, so that if either of them changes, this hash key, there is a mismatch, okay, that is flagged. An SPDX requirement child, for a child for derived requirement. And then there is SPDX requirement sys. I cannot remember, to be honest.
Which subsystem this is?
Yeah, exactly. Which subsystem? Well done. And then we have the SPDX requirement text. That is the main body of the requirement. So that is where we describe the expectation from the requirement. Okay, so that is all the semantic part associated with the requirement. And then there is an SPDX requirement note for any informative note that is not formally, part of the requirement specification. Okay. And so this is effectively, the requirements format that we put together. This was presented at the workshop at NESA, and the main feedback, I think Steven Rosted at that time was there. So the main feedback was, this is quite a lot of stuff, and it is pretty, hard to digest. So before we go up to the community, to the Linux, proposing, to implement this format within the Linux kernel development process, indeed, we should first show the value. Okay. And so what we did is, okay, so at the time there was quite some excitement. We said, okay, now let's, for 1 second, let's put aside all this table. And let's focus on SPDX requirement text. So let's focus on putting together code specification that are compliant with the current kernel doc header format, but in a way that is testable, right? So we wanted to implement testable code specification, okay? Something that can be appropriate for a requirement text. And yeah, so we did. So yeah, so basically we started the sorry, I missed this step. So basically here, this is where before moving to the code specification. So this is an example of requirement. Okay, so indeed, the requirement should be testable, maintainable in line with the source code, compatible with the pre-existing kernel documentation, and also hierarchically traceable. Okay, and you can see on the left here an example. Here we have a requirement ID that can be automatically generated. Then we have the SPDX requirement text. This is the actual specification. Okay, so this is where the subject matter expert has to define what the expectation from the code are. Okay, and here you can see that in terms of code expectation, here we have a sequence of events. Then we define the different return values depending on different conditions. Okay, so this is a sort of a more informal way define specification compared to the formal model that we were discussing earlier. Right? And now the main challenge here is to identify the design elements to be documented. As it was mentioned, if there is a print K that is not, usually that is not, a design element that we want to document. Okay. So, and on the other side, if we try to model everything, we would come up with a degree of complexity that is, it's like pseudocode written in a different way, right? So it doesn't make sense. So really, the key issue here is finding the right trade-off between pseudocode and something that instead is too vague. Okay. So on that, so basically another thing that we did. Actually, this is what Alessandro did, that is here. So he created a script to automatically generate the requirement ID. Okay, so this is something that we know that we need to have some automation, and SPDX rec ID is the first thing to be the first field to be automatically generated. And then indeed the other one would be, as already mentioned, is the hash key that is generated every time the requirement change or the code change. So basically, every time there is a contribution, the hash key is updated. If it is the same as the previous one, then it means that there is no change. Otherwise, it raises a flag to the maintainer and says, hey, you need to have a look at that requirement. Okay. So this is, this is what we did so far with respect to the requirements framework itself. Okay, but as already mentioned, for the time being, we have kind of parked this. Okay, and we are now focusing mainly on getting code specifications upstream. Okay, because without showing the value, all of this is unlikely to end up upstream, unless there is some miracle. And yeah, so, and this is an example of one of the, this is one of the latest submission that we did. So for submitting code specification, we decided to use two different subsystems. So actually, one driver and one subsystem. One is the tracing subsystem, and the other one is the driver for dev memo. There is no, I mean, from a safety perspective, we haven't chosen this because there is a safety requirement specific. The reason why we chose these subsystems is because we had good feedback, so from the respective maintainers in terms of acceptance of this code specification, or at least we thought that this was the idea. Okay, so basically what we did is we submitted this code specification. These are sitting right. So if you click on any of these patches, you will see that these are sitting right on the top above the functions that is being specified. So this is inside the C file. This is compliant with the kernel doc header format. Okay, there is what we are doing here. We are effectively expanding on the code behavior in a way, introducing a formalism. Okay, so effectively here, we are defining all the different code expectations one by one, and all of these are written in a way that is testable. This is not a test case, so it is testable. It means this should be sufficient for a tester to write one or more associated test case in a way that is not ambiguous. Okay, in order to write the test cases, you also need to go and read the code. Otherwise, it is practically impossible. Okay. Okay, good. So what we did is, okay, let's go. We have informal agreement with the maintainers. Let's push this. And okay, so we pushed this function here. Okay, and then the main feedback was where is this format documented? Who will be parsing it? And this is totally legit, because to be honest, what I did in the first submission, I submitted this, but I never documented anywhere what a function expectation is. Okay, so for example, it is impossible to know how to use these, how to interpret this. And that's fair. Okay, and another feedback was that it is better if in the next submission, together with the specification, you also push some tests associated with this specification. Okay, brilliant. So what we did is we worked on the second patch set of this submission, and basically what I did, the first patch of this patch set contains the guideline for writing testable specification. Okay, and then we got some feedbacks. So the first one was from Jonathan Corbett. Jonathan Corbett is the official maintainer for the Linux kernel documentation, if you're not aware. Okay, and he said, yeah, what I still don't really understand is what the purpose of this formalized text. What will be consuming it? You're asking for a fair amount of effort to write and maintain this description. What's in it for the people who do that work? How does an author determine whether the specifications they've written are correct, both grammatically and semantically? And the other one is from Greg that said, step back, tell us exactly what files and functions and APIs are needed to be documented in this stilted and formal way. Who is exactly going to be doing all of that work, and why we should even consider reviewing and accepting, and most importantly, maintaining such a thing for the next 40 plus years. That is, that was not really encouraging, to be honest. So, but basically, what we have realized is that so to some extent, the maintainers do not understand why this is really needed and what is the value behind this. Right. So and now we don't know how it will end, but basically what we are doing is we are working on a revisited patch set. So if you click here, you can see the ELISA private GitHub repo. I mean, no, sorry, it's a public GitHub repo, but it's not the main line. Okay, so it's a branch. So in this public branch, we are working on the V3, and this is not the full addition, okay, that I'm doing. It is just trying to capture the main point, okay. So, and here I've tried to explain why, how, and when, okay, to apply this guideline. Indeed, why? Because integrated users clearly know what to expect without going through the complexity of code internals. Developers can verify if their proposed modifications are coherent and consistent. Testers can test the code against the documented intended behavior, hence without the risk of mistaking a bug for a feature. And how is one of the points is, I think one of the concerns from the maintainer was who is going to maintain this. Now, to be honest, I think most of the effort is associated with writing the specification, not with maintaining, because once they are in place for a certain function, it should be pretty straightforward to evaluate code changes against the specification. Okay, and if you're a maintainer, you can also say to the guy who wrote the patch, please also update the specification other than the code, right? If you find a mismatch. So, in my opinion, it should be effectively down to the individual contributors to write such testable specifications, and the maintainers are expected to review them against the pre-existing code and eventually accept them. Once upstream, it should be easier for new contributors and maintainers to verify code changes, and also for testers to write associated tests. So, effectively, to be honest, maintainers should be happy about this code specification, because once these are upstream, it is less likely that a new developer send out, wrong code because he had a wrong interpretation of it. So basically, if I have a wrong interpretation of a certain code, I make a change because I thought that it was doing something and I made a wrong change. The maintainer need to waste time to respond to me, and then I need to waste time in writing their patch. So all of this ping pong, in my opinion, is also part of the technical debt. Right?
And then there's all the security people.
And there is
fix things.
Exactly. So we discussed this in the last architecture working group meeting. So this extract is not containing all the nice feedbacks that I got, last Friday. But yeah, so in general, yeah, for example, also like another point that came up, if I need to rewrite a piece of code in Rust, if I have the specification, it should be much easier rather than reading the code, interpreting in my mind what the code is expected to do, and then I don't know.
We have a test to the specification, to
Yeah.
the requirements specification. Then
Exactly.
once you move things over from one language to the other, you can also say that yes, it suffices. It actually is, matching to the data. So
So, and then when one of the other feedbacks was how many APIs do you intend to document, right? All of the Linux kernel. Now, I know that for the avionic guys, for avionic standard, we need all the functions to be documented. But in general, the general principle is that everybody will document the functions that are most critical to him. Red Hat will start documenting functions, for example, maybe some symbols that are used by some hardware vendors for their drivers, for example. So Boeing may decide to use, to document, I don't know, functions that are that are found interest in that specific use case. So, but this is the idea. I mean, this the guideline anyway is fully compatible with the current kernel doc header format. It does not impose a strict change in the Linux kernel development process. It's just additive wherever specifications are needed and more tests are needed. So yeah, so now this is the idea is to to announce the current guideline also with all these context explanation and why we are doing it, this, how, when, and then let's see. But as of today, the outcome is unknown. So
Like most things in the kernel, you just have to keep being persistent and trying over and over and over again.
Yeah.
So we're on our journey.
And from a
So-
maintainer standpoint, the real important thing we would need is just sign off. Did whoever's maintaining the specification actually address what's going on? If we can show that traceability where a maintainer goes, yeah, you got it right, that's a huge thing. Right now, anybody writing requirements for the Linux kernel, privately in the background in a proprietary sense, thinks they've got it, but they don't. They don't have any maintainer signing off saying, yep, you met the intent, spirit, and reality of what this code's supposed to be doing. There's always a loss whenever you have an idea in your head and you convert it to code, you're losing information in that act. It's just that when you write code for a long time, and you talk to other developers, your experience allows you to fill in the gaps, but it's never perfect. That's why even with senior engineers, there's always room for misinterpretation, even when you're both staring at the same code. And this fills in that gap. It's really not about safety, security, anything else. It helps those things, but it fills in that gap, that loss when you convert idea to code.
Yeah. One of the encouraging comments we got from Steve Rosted when the work was being done is the fact that, it makes some things clear that you have to keep on refiguring out each time you went in. And by doing that subsystem, we also found a few bugs that got fixed as well.
yes, yeah, we yeah.
So it improves the quality from that perspective.
There's a bug that I fixed. I sent out the fix by myself, and another one that was. I mean, the one that Steven sent out was not really a bug. It was an improvement. There was redundancy within the code. So basically, he removed a redundant parameter that was not really needed. So yeah, but I don't know. I mean, if maintainers stick, to the mindset, you already have the code, just read the code.
Well, like I say, this is technical debt.
Could you not also see this as a cumulation of all the Git commit messages before, because there you also
So-
implement your intent and so on, and then it changes because somebody has another intent when he expands on a certain function. So it's more of a cumulated commit message of all the authors before. So and nobody says you don't need a commit message.
We have ways of mining our commit messages, and that's part of the thing, but, and that's certainly aspects for formulating things in weird areas that no one's around. Maybe aspects of that. The Craigit stuff will let us go into history and then things like that. So we've got capabilities, and we've got, the breadcrumbs, but getting a format such that we can actually collaborate on this so that we can actually do the safety analysis at the right level is going to be a systemic type of property that we are going to have to be politely persistent for a couple of years, I
Yeah.
suspect.
Yeah.
But, documenting it, but if we want the kernel to keep being useful for the next 50 years, a lot of people are going to be retiring in the next 10. We're going to be having people, transitioning out. There's parts of the kernel right now where they're, as not as well maintained as they should be, and no one wants to touch and fix things in them because then they own them. And we need to get past that. And so this is at least a structured approach for qualifying some of the technical debt and putting a framework in place so that we can have the easier onboarding of new maintainers, as well as the security people who can do to fix things and so forth. So from that perspective, it's worthwhile spending the effort to try to get the sustainability up on the kernel, given the fact that the kernel is one of the most important open source projects out there. Go ahead, question.
Yeah, so I think the best approach would be if someone steps up to maintain that as a separate subsystem, maybe. These requirements, because
Oh.
most of the maintainers are volunteer, right? So you cannot expect a volunteer. I am speaking this as
Yeah.
like maintainer, not as part of ELISA. I have few drivers which I maintain. I have my name in the maintainers list.
Mhm.
As a volunteer, if you asked me to maintain your requirements, I
If-
am.
if- Well,
Please.
are you okay with maintaining your documentation on your things? Because this is just documentation.
The document is very less.
Well, that's the problem, right? And
Yes,
sorry, and the thing is, at Plumbers last year, we thought sidecar, okay? And the maintainers in the room then told us, no, it has to be inline or it'll die. It's done, it's dead. So having a separate requirements repository off to the side was a non-starter for the maintainers in our room at Plumbers last year. So we've got a lot of opinions of maintainers out there in the kernel. We're trying to make it low.
And once
low-hanging.
once you see a well decomposed function defined with good requirements, you'll realize how limited your existing documentation actually is. It's not as good as you think it is.
But then how do you, someone volunteer to do that thing?
Oh, we're not, so we're not asking.
I think that's the misconception here. If you're fine to maintain requirements, fine. If you're not, I mean, this is something the community needs on the long term. There needs to be people stepping up, people like Gab, Chuck, Alessandro,
Not
that do
kernel.
that effort, and then
I'm sure Gab and Alexander is not doing that part of volunteer, right?
Well,
It's probably a separate maintainer path to write these requirements. There's a linkage between the code writer maintainer and the requirement maintainer where they say, yeah, you got it. There has to be that. So at least read what we wrote and say, yes, this is accurate. Okay, then we have that linkage. No one else in the world can get that. That's the only place you can get that is by the maintainer. So they don't have to write it. We can have a separate requirements maintainer. It's just a linkage, a sign off. Yes, you got it right.
I think we need, hold on a sec. So I think we need to distinguish. When it comes to the semantic part of the requirement, that would be the same maintainer. Because otherwise it would be more work effectively.
Initial acceptance is okay, but then who is going to maintain? That will be the.
well, so the question
But
is,
then
when are you accepting the
If
code?
some function changes, you.
Yeah, if the function changes, okay, and we know that the requirement is associated with the code, whoever's changing that code should needs to look at the requirement as part of cleaning it up, and that's going to remove the technical debt.
So if I am the maintainer, right, you send me the code change without changing the specification, okay? I'm the maintainer, I will come back to you saying, you change the code, but you haven't changed the specification that's it on top. Please update that as well.
So who is going to do that? The maintainer has to.
You.
Do that committer to.
You, the developer, the guy who sent
Or
out the patch.
you are, when you are adding the initial requirement, are you going to have keep an eye on those things, and are you going to come and say that this has not been updated?
That's what the hash key is.
Hash will
You
let
can
you-
have CI trigger that for you. It's automated.
Automated.
Yeah, we're trying to do the automation as much as we can.
Automated will be, I think.
Yeah. But you see, it would be like a ping pong, like today, the maintainer only just look at the code, right? Tomorrow, you also the specs. Say, hey, you send out the code, you haven't changed the specs, right?
That will be, I think, more acceptable than the maintainers to have.
But we never asked, yeah, exactly.
Yeah,
nobody
we're
wants
trying-
maintainers to maintain requirements, because that's.
Yeah,
Not every maintainer is a requirements engineer, not every code is a requirements engineer, that's a separate task. But if you need to bring in a third person or third party to add to this value, then it is.
I think the key here, there's a whole community of experts out there on the safety side who do not have a valuable way. They're having to do things bit by bit inside companies, and we're not sharing that. This could give us a framework for sharing analysis and sharing the, and quite frankly, working with the kernel CI community and some of the other testing infrastructures to automate the testing so that we can be much more precise and efficient in our testing going forward as well. Okay.
Sorry for being long. So I think a well-specified tested code is the best thing we can arrive from a quality level. And I agree, not everyone can read and write, as I always like to say about Adidas employees, because hey, not everyone reads emails and writes emails, but some code more and other specs more. But having an agreement that a well-specified and well-tested code is, let's say, the aim where we should go, is at least that everyone can contribute as his best. It's not that, and if I don't do something really perfect, yeah, well, then I write a specification for it. So that's at least something. And if then someone else comes and says, Oscar, you implement it slowly and we can do much better, I can do this for you. I'm so happy with it. But having a good specification allows them to improve this and have it. So this is just the area I think we should go.
I mean, you know, the point, I hear that, right? So it's a lot of activities. You have tried more or less and failed, right? So no one wants to do this.
No, I don't, I know, I'm not gonna, I disagree. We have not failed. We are
Okay, but
basically, we are exploring this
It's
space.
called like first iteration, right? So
Well,
for the
V3
first
now.
iteration, you get the feedback from the community. They say that they don't see any value in that. You try to improve. Well, like what would be the next
So
steps, right?
all I can
So, like,
say is preempt RT took 8 years to get upstream.
well, 17, I think.
Well, possibly, but eight,
Yeah.
I was involved in, you know, for 8 years of
Yeah.
it, at least from the behind the scenes part. And so the only way it got changed upstream was to, quite frankly, clean it up and make it better, quote unquote, in all these subsystem areas. We're going to be going through the same exercise here, and there was multiple times where things were rejected and back and forth for 3 or 4 years. That's just how the dynamic of the kernel community works.
Right.
Okay,
Right.
and so we are trying to explore a format here that will help, that will satisfy the needs of the safety analysis community, but will also be acceptable to the kernel community, and quite frankly, reduce technical debt.
I mean, I completely agree with you. The argue here is like no one wants to read to write documentation, right? So you have mentioned real-time patches. There is definitely, I mean, the value behind that, right? So it improves Linux like determinism and real-time behavior and all of this stuff. Now with introduction of requirements, I mean, I completely understand the reason because, right? So, but I think it's much more difficult to convince people of using it, right?
But so the question is, how do we lower the barrier so that the maintainers see it as an advantage? Okay,
Yeah.
that's how they got preempt RT upstream. It was seeing it as advantage and cleaning up debt.
Have you tried to use maybe, you know, to use AI to generate requirements?
We played
I
around.
mean, you know, you have a description of how to do this, and then you have examples. Then based on examples, try to, you know.
On this one, there was directly the comment when we in the patch said there was not meant like this, but there was actually a comment. This sounds like you want to use a kind of an AI tool. Go away with it. I don't want to hear about it. So this was
Yeah,
more-
we're not bringing AI into this. That's not even part of the discussion.
But what you just said, I mean, last year at Plumbers, we were first time discussing it. And it was, the base of it was actually shared there. And in discussion, the Kent subsystem maintainer comes from the automotive space. He said, oh, I would be interested in looking into it and bringing it in my code. I understand the value, and the security people may also see value there. The kernel CI people said, if I would have requirements, I actually have something to test against with. And we were talking about thousands of maintainers. Maintainers, this is quite long, so there's a huge set of maintainers in there. And of course, not everybody will automatically adopt, but if we have a method to bring this informally, if we see first requirements, then it can also be something that you start writing your requirements and you start maintaining requirements, use this methodology. And if you just bring in like this thing as a kernel patch locally, apply the tool which Alessandro has, then you can get an argument that this code part has changed. I have my hashing over it. I assess it again. And this was actually what a guy at the old Linux Foundation Member Summit told me that, like, when you bring in this requirement thing, I as company have tool and methodologies to argue that I avoid regressions on security issues, which I fixed in a time where I don't know if it's still fixed after years. Like where changes get in. So there were actually also people saying, like, it is possible, but you need to at least pick up some people and say that's the way where we can go, and this can be the way, and maybe it will disappear or be replaced by a better thing, but it's just starting.
Yeah, I think, writing requirements is a one thing. And another thing I think should be a possibility. It will be a talk about street dog. NASA has Pratt, for instance, for writing requirements. You really need to compile those requirements, right? So and
Well, so these compiling these requirements, okay, we need a format that we can export them so we can do systems. That's what
Yeah.
we're working on with SPDX. Import, export requirements, traceability. If we can get that in a neutral format, we can start to compose systems and have different tools working with it all. And that will let us do the analysis up to the system level beyond just the component level.
yeah, because you need to compile requirements for consistency, for
Correct.
instance, right? So
Yep.
It's not enough just to write requirements.
Mhm.
Oscar.
Let me say on the requirements in AI, so the reason why I thought being timeless, I brought on a rather theoretical research meeting and was presenting about AI generating contracts, which is theoretically possible if the AI would be good enough. The only thing that I think that AI cannot generate is requirements. Because this is something the human has to say what he wants, and that the AI can help with coding or do something. So this is definitely something. But I also agree that for many programmers, starting with an empty sheet of paper is something very difficult. So, and then having something that generates a proposal, but then reading it manually and committing it or acknowledging it, this is something that the human has to do first.
Definitely. Because otherwise you cannot distinguish between a feature and a bug.
If I can avoid this generate, do I read this? And if I see an AI generated text,
And you don't know what's intended with. You don't know what is intended. And the intended functionality, I guess, is what is the important, what is the important.
You can assume that intended functionality will source code, right?
no, it's like very proud, especially Gap will be very proud because he has written the specification and he found a bug in the code. Hey, isn't this the best thing you can do here?
Yeah.
So if I would have the choice writing a code or writing a spec and finding a bug, I would choose to write a spec.
That's your.
The truth is in the code. The code is a requirement. If this would have been the truth, no planes would fall from the sky. No cars would crash because of some.
I didn't say that the source code is the truth. I say that you can use the source code to generate the requirements, and then you can review these requirements, and fix them.
That's
But
I think
it-
is a
it's
very
different
valuable
thing.
exercise. Either have Gen AI or some person reading the code, coming up with requirements, and then getting into the communications and, hey, is this really what you have intended with the code? I think that's even, at least in what I've seen the last 1-2 years, it's more valuable than this bottom-down approach to say, I've written a requirement, I'm not even sure how to implement it, and then the implementer needs to prove that this is the requirement before.
But just on wording, if we take the code and extract its meaning,
Mhm.
that it's not the requirement, it's the status quo.
Yeah, but
That's the point.
but
The big question then is, does the status quo actually match the requirement? Yes or no?
That's the thing.
But this is what we've done in practice. When we wrote the code specification, and sorry, there is the column.
Yeah, I think with
So,
requirement.
Yeah, you can hear me. And so when we basically wrote the code specification, we read the code and we guessed from our understanding what the intended expectation, what the intent of the code was. And then looking at it is like, we figured out, oh, I think there is something wrong here. And we asked Steven, and he said, oh yeah.
It's just,
Say, the more eyes makes, by more eyes improve the quality. This is yet another set of eyes on the code. And it will help, as we have it documented, then the quality can be we're improving quality in some senses. By bringing in a whole new community of experts to basically be able to look at the code and provide feedback on it, doing these requirements.
You said there was a mismatch between what the function actually did and what was documented, if I get it right.
There was a, I will show you, it's pretty easy. Right?
And my question now would be, did you try, would it have been possible to answer this original intent from reading all the commit messages back to 1990, reading all LWN articles, reading all mailing lists? Would the truth be in public data, or do we really have to interview subsystem maintainers? That is the question.
I mean, to be honest, I don't know. I mean, for me, it was easier to read the code and try to determine what the intended behavior was, rather than going. I mean, can you imagine how many? I don't know. I mean, on average, if you take a function of 30 lines, maybe there are behind that there are like 40 commits, even more. Like,
Oh, yeah,
it's even more.
this part's the thousands.
So I think it's this is for next. I'll find it now. But please, this one. Yeah, actually the bug with I found. So basically there was a return value that was missing. So basically an event register failure was silently ignored. In fact, this was ported. You can see that here there is the sign off from Sasha, that is the LTS maintain. So this was backported to LTS. And also the other fix that was from Steven. But I mean, it's not. It's an improvement. In fact, this patch is for next. It's this one. Yeah. So basically, there was a flag that was redundant. So yeah, just saying that all this activity, there are some results.
I mean, Gabriele, so you say it took like a couple of decades to merge these RT changes, right? So now we can assume that it would be the, let's say, similar time frame for the changes we want to make.
For full
Right,
coverage.
right. What
I think the parts that are most important.
what you will do, or what will this community will do during this time?
So those who have commercial interests,
Mhm.
who are selling things that are that way, have much more motivation than the maintainers do. Doing the analysis and sharing it so that you get the confirmation you're correct will help with your business cases and will help motivate this contribution upstream, and other eyes can look at it and say, oh no, or yes, okay. But the parts you care about the most for your business cases, you're going to be more motivated to contribute. And so as a result, I think the things that are most critical from the kernel, from various market segments, the CAN drivers for automotive, for instance, will probably get documented for the automotive sector. There'll be probably other parts and other subdrivers and subsystems.
The watchdog subsystem.
Right.
Quite critical.
Watchdog, things like that. Things that people care about will get documented faster and required faster, because they'll be used.
Mhm.
Okay, they'll be used in the analysis. And then I think it will spread throughout. And quite frankly, 20 years from now, if there's parts that don't have requirements, the question is how much are people even using it? And is this a way of pruning down the kernel to something that's more sustainable? But the other side is if we have these requirements in and someone wants to move from C into a memory safe language like Rust, you also know that it still works if you've hooked your tests up to your requirements. Which Brandon is going on. Like, how long will it take for the kernel to move over to Rust? Well, it's starting. It'll probably take another 10 years, but if we can start to put some of this in, we'll have a much more solid basis going forward for things.
Okay, so this is what we've done so far. And another thing is the strict doc experiment that is ongoing. But we have the next session that will talk about this in detail. So we are experimenting strict doc as a requirement processing tool. This is more associated with the maintenance of the metadata requirements, like all the SPDX fields, basically. And so the next steps, I think we have talked about RFC patch v3. So I showed you, the rework in the guideline. And Alessandro is also reworking the kernel test, shifting from KSF test to KUnit. And so we'll send this one, and yeah, fingers crossed. Plus, we have two sessions that will be held at Linux Plumbers. One is adding testable code specification in the Linux kernel, and the other one is defining, so adding testable code specification in the Linux kernel is accepted for the referee track, whereas the second one is for the safety microconference. So, the first one is only focused on code specification. The second one is more focused on the requirements themselves with all the different fields and stuff. And in parallel, we'll keep working on the strict doc integration and see, hoping that RFC patch v3 gets some good feedbacks.
You have mentioned the current documentation covers how many percentage of the functions?
It covers 10% of the exported symbols. But consider that exported symbols are not. So exported symbols are functions that can be used by out-of-tree drivers. Whereas, sorry, by by out-of-tree drivers, yes, correct. But there are also many functions that must be documented that are those associated, especially with the file operation, and these usually are not exported symbols. They don't need to, right? But these are very, very important. Like the read, write, and map callbacks, all these kind of things.
Well, I can add that by default, Linux security modules are not made modules by choice because they need to remain inside the image. They cannot be a module, and they have no exported symbols. But if you want to do one of these, you need to use function and APIs.
How will we want to deal with like an NVIDIA driver? Something which is closed source and never will be open.
NVIDIA drivers.
Yeah.
Well, I'm assuming that the NVIDIA people, if they follow this methodology, they can, whatever we do in the kernel, they can do within their own scope. Okay? And whether they make it visible or not, their customers will probably have to make it visible to the safety assessors.
But the best, in general, if there are out-of-tree drivers, the best we can do is we can document and specify the symbols that are used by these drivers.
And whoever has the commercial interest in those drivers is the ones who'll do the work at the end of the day, or they won't sell their silicon. The same way we were told 20 years ago, if the code isn't upstream, we're not buying your silicon when we were in the Linux kernel, right? I think you'll see that emerge in 10 years. Any, well, I think, we'll see.
I hope, yes,
That's-
for Red Hat, it will make life much easier.
Yeah, I think it's step by step, right?
It's a step by step.
Yeah.
Exactly. Okay, well, I think we are
Good in timing.
good in time, and I think we're ready for, to probably swap off for the strict up, so, yeah, please talk to Gab and myself in the halls if this topic is interesting to you, and help us strategize further on this stuff. Okay? Thank you.
Would you stop the recording?
Actually,